Right, so the idea in simplifying this radical is you can't combine root 5 and root 20. However, root 20 is not in its simplified form, right? What perfect square factor can you remove from 20? So this is like 4 times 5. So you have this root 5 plus this 6 times. So the root 4 comes out as a 2, and this factor of 5 stays inside. So really what you're looking at is root 5 plus 6 times 2, or 12, root 5. And when you combine these, and this is again a part that's sometimes tricky at first, is you think of the coefficient or the multiplier in front of the radical here. 1 root 5 plus 12 root 5. The root 5s just carry along, because really what you're doing when you combine these is you're taking these two terms, you're removing a common factor of root 5, and that leaves you with a 1 in the first term and a plus 12 in the second term, and that's going to give you 13 root 5. Now, most of you don't do it that way, right? You guys have all been conditioned enough to see that 1 root 5 plus 12 root 5 is 13 root 5. Okay, but the process that you're using is really just you distribute out the root 5, combine the numbers in front, and that becomes your new value out front. Okay. But you don't have to. You can just combine them like you would any other like terms. And the only way you can combine radicals is if they are alike, the terms are alike. So the index has to be the same. The radicand, which is again the name of the value that's inside the radical, has to be the same. That's the only way that you can combine them. Okay, so I want you to try this. It's a little bit tougher problem. Okay, that's a 14b there. Okay, so see if you can simplify this expression. Okay, so 20 root 72a cubed b to the fourth c minus 14b root a, or 8a cubed b squared c. Okay, see if you can combine those after you simplify. All right, so I'm going to talk through the process, and that is to simplify each individual radical first. So looking at my first group here, I have my 20. I'm going to leave a space, and I have work with my radical, and I'm going to work with the values outside the radical. So first I'm looking at 72. Okay, are there any perfect square factors I can remove from 72? So 36, root 36 comes out as a 6. The 2 stays where it is. Okay, what about the a cubed? Again, I'm looking for whatever my index is, which in this case is an unwritten 2. So how many groups of 2 can I remove from my a's? 1, leaving how many a's inside? Okay, how many groups of 2 can I remove from my b's? 2, leaving how many b's inside? 0. And how many groups of 2 can I remove from my c's? None, leaving how many c's inside? 1. So when I simplify what I have here, 20 times 6 is 120 ab squared, all times root 2ac. So there's my first term. I can now move to my second. I have my 14 and my b. I'm going to leave a space to continue to work with the things that I can remove from my radical, and I leave my radical. So looking at 8, are there any perfect square factors you can remove from 8? 8 is 4 times 2. The square root of 4 comes out as a 2. Factor of 2 stays inside. How many groups of a's can I remove? 1 group of 2 a's, leaving 1 inside. How many groups of b's can I remove? 1, leaving how many inside? 0. And how many groups of c's can I remove? Groups of 2 c's? None. So that leaves that c inside. So when I simplify what I have here, 2 times 14 is 28. B, or a, is by itself. B times b is b squared, root 2ac. And so what I'm looking at here is my like terms. Here's the quantity I can technically remove as a factor out. So ab squared root 2ac gets factored out, but I'm just going to leave it as it is. And the 120 minus 28 gives me my number in front, which is 92.